This module covers general information about the Exhaust Gas Recirculation System, or EGR, functional test, and smog check inspection procedures. It is not all-inclusive and does not replace or supersede any applicable Smog Check or Automotive Repair Act laws and regulations. During this presentation, we will review the basic operation of EGR valves. We will also describe EGR testing procedures and provide videos to demonstrate how to properly test EGR systems while performing a smog check inspection. Combustion produces heat. If uncontrolled, excessive combustion temperatures increase NOx, leading to the formation of photochemical smog and ground-level ozone. The EGR system works by recirculating a portion of an engine's exhaust gas back into the combustion chamber to reduce peak combustion temperatures. This inert exhaust gas displaces part of the fuel charge in the cylinder. It is important to know that test procedures for EGR systems can vary greatly. Therefore, it is critical to use all available resources and reference materials to perform the proper test procedures for the vehicle being tested.
When trying to determine if the vehicle you are currently testing requires a visual or functional test of the EGR system, please refer to the test requirements table found in the latest iteration of the Smog Check manual on BAR's website.
In this section, we will discuss ported vacuum, Venturi vacuum, positive and negative back pressure, computer-controlled, and digital EGR systems. The next few slides explain these systems. Not all components and systems are the same. Some are quite simple and others are complex. The key is to utilize all available resources and reference materials when inspecting and diagnosing these systems. The ported vacuum-controlled EGR system uses a vacuum port above the throttle plate to supply vacuum to the EGR system when the throttle plates are opened. As the throttle plate is opened, more vacuum is applied to the EGR system. If the engine is cold, the coolant temperature switch will be closed, blocking the vacuum to the EGR valve. If the engine is warm, the temperature switch will open to allow the vacuum to be applied to the EGR valve, and the EGR valve will open to allow exhaust gas to flow into the engine. Under hard acceleration, manifold vacuum decreases to almost zero, and the EGR valve closes. Vacuum controls the EGR system and comes from the venturi of the carburetor or throttle body. Venturi vacuum is highly sensitive to changing engine conditions, providing the most accurate source of EGR control. In some EGR systems, a vacuum amplifier regulates venturi vacuum and manifold vacuum to deliver a strong and consistent vacuum signal to the EGR valve. There are two types of EGR valves that rely on back pressure for operation: negative back pressure and positive back pressure. Both types of valves have a vacuum bleed inside the valve itself. The amount of back pressure determines whether the bleed is open or closed. In a negative back pressure system, the valve is opened by a combination of applied engine vacuum to the control valve and negative exhaust system pulses. These reduced back pressure pulses occur when each exhaust valve closes. The positive back pressure system valve uses exhaust pressure to regulate flow through a vacuum control valve. The stem of the EGR system valve is hollow and allows back pressure to enter the bottom of the diaphragm. When sufficient exhaust back pressure is present, the diaphragm moves up and closes off the control valve. This allows a full vacuum signal to be applied to the upper portion of the EGR system diaphragm, which opens the valve. A computer-controlled EGR system lets the computer adjust the EGR system operation. The computer adjusts the EGR operation based on signals from various switches and input from the coolant temperature, throttle position, mass airflow sensor, manifold absolute pressure sensor, park neutral switch, and other devices. Pulse width modulated EGR valves use short electrical pulses sent by the ECM to the control assembly solenoid to regulate EGR function. The digital EGR system valve operates without the use of engine manifold vacuum. Instead, it controls the system flow through three orifices that are opened and closed by electric solenoids. The solenoids are in turn controlled by the Electronic Control Module, or ECM. The ECM uses input from the coolant temperature, throttle position, and mass airflow sensor. In the next few slides, we are going to demonstrate how to test the EGR system on this 1995 Ford Taurus with a 3.8-liter V6. The Taurus's EGR valve is actuated by vacuum, like in older model vehicles. However, the vacuum source is ported through an EGR vacuum regulator, or EVR, solenoid that is controlled by the Powertrain Control Module, or PCM. The PCM outputs a duty cycle to the EVR, which regulates the vacuum level to the EGR valve. As the duty cycle is increased, so is the vacuum signal to the EGR valve. The PCM relies on input from various sensors such as engine speed, engine vacuum, exhaust system back pressure, coolant temperature, and throttle angle to determine the correct amount of exhaust gas recirculation. The inspector needs to use an Emission Control System, or ECS, application guide to find the proper EGR test for the 1995 Taurus. As shown in the slide, the appropriate test number is identified by vehicle make, model year, and engine size. The correct EGR functional test procedure for this Taurus is test number 11. EGR test procedure number 11 requires both visual and functional checks. Pay special attention to the notes since they are instrumental to the testing and diagnosis process. To test the EGR in this vehicle, a handheld vacuum pump is required to operate the EGR valve, and a tachometer is required to measure engine RPM. After verifying that the vacuum hoses are properly routed, connected, and in good condition, run the engine until it reaches normal operating temperature. With the engine at idle, check the vacuum supply to the EGR for a vacuum signal. The EGR solenoid is designed to have a constant internal leak, so the vacuum signal should be less than 1 inch of vacuum at idle. Install a tachometer to read the engine RPM and disconnect the engine's idle air control solenoid. Disconnect and plug in the EGR vacuum line. Using a handheld vacuum pump, slowly apply vacuum to the EGR valve. The EGR valve should open and the engine should stumble and start to die. The idle speed should drop by more than 100 RPM and recover to normal RPM once the vacuum supply is released. The drop in RPM and the engine stumble indicates that the EGR valve was opened and the EGR passageways are clear. Testing the linear EGR valve on this 1995 Oldsmobile Delta 88 with a 3.8-liter V6 engine requires the use of a scan tool. There are many types of scan tools that are slightly different in the way they operate. During the EGR functional test, the scan tool will verify that the EGR valve is functioning and that the EGR passageways are clear by electronically actuating the EGR valve with the engine running. Here is a diagram of the linear EGR valve found on this Oldsmobile. The pintle in the center of the diagram is controlled electronically by the vehicle's PCM. As the electric solenoid pulls the pintle, passageways are open and exhaust gases are drawn into the intake manifold. Here is the linear EGR valve on this Oldsmobile. The EGR valve is PCM controlled and has no vacuum hose connections. To find the proper EGR test for this vehicle, the inspector will need to use an ECS application guide. The appropriate EGR valve test procedure can be identified by locating the correct model year and engine size. The EGR functional test procedure for this 1995 Oldsmobile Delta 88 with a 3.8-liter engine is test number 27. The EGR test procedure for this vehicle requires the use of a scan tool to actuate the EGR valve. In Test Procedure 27, inspectors are required to check the onboard diagnostic system for trouble codes and correct any that may be present. The inspector must set up the scan tool to match the vehicle being tested by connecting the scan tool to the OBD diagnostic link connector. Once the scan tool is set up, the inspector must choose the scan tool's EGR test. The following video shows the process of testing a linear EGR valve with the scan tool. Not all scan tools operate in the same manner. The EGR test shown in the previous slide indicates that the Tech 1 scan tool will automatically cycle and open the linear EGR valve from 25% to 100%. The scan tool in this video does not automatically cycle the linear EGR valve. The inspector will have to manually cycle the linear EGR valve from 0 to 100% to achieve the same result. Carefully listen to the vehicle's engine RPM drop when the inspector cycles the EGR valve from 0 to 100%. When the EGR valve is opened to approximately 80%, the engine begins to run rough and the RPM starts to drop. As the EGR valve opening is increased from 80% to approximately 90%, the engine starts to stumble and die. The RPM drops, indicating that the EGR valve is open and the passageways are clear. Carefully watch the digital readout. The areas marked with yellow arrows in this photo display the EGR opening as a percentage, the engine RPM, and a graph shows the RPM drop. Regardless of the scan tool used, the result should be the same. The EGR valve is cycled open, the engine RPM should drop, and the engine idle should become rough, indicating the passageways are clear. You should now have an understanding of the function and importance of the EGR emission systems, recognize the different types of EGR system valves, have a working knowledge of the vehicles that are required to be tested, and understand how to test them. You should also know how to read and interpret ECS application guides, understand EGR system functions, and be familiar with some basic testing procedures. Thank you for viewing Module 8 of the California Smog Check Program Training Series.